Hello viewers, today we are going to deal with dynamics. Of course, this question requires us to know how to calculate for the mass of this object if the objects are static. If the objects are static, whereby we've been given the information already in the question, which is above there, the coefficient of static friction is given as 0.2. The mass for the first object here is given as 2 kgs, but the mass for this one is not known. So when the object, or rather a system, is static, how do you get to find the mass of the missing object? In this case, if we come to this given object, you notice that when you use the second law of motion, you say the summation of forces in X has to be equal to 0. Why are we trying to equate it to 0? Because there is no motion for that object. So the tension here has to be a positive force. The friction force is taken to be the opposing force. So I'll say tension minus the friction. This will be equal to 0, meaning that tension is going to be equal to the friction force. That is according to that given object. When we come to this given object, we will notice that tension and that one, they are also having their own motion. If we try to assume that this object was to move downwards, meaning that this one is going to be a positive force, that will be a negative force. So from here, we'll say the summation of forces in Y is equal to 0, because there is no motion again due to the fact that the system is static. So this one will be taken to be positive. I'll assume that it was a positive force, which is the weight of the object, and the tension itself is a negative 1. We equate the sum to 0, meaning that mass multiplied by gravitational acceleration is equal to the tension. From this given part, you also notice that the tension which is attached to the second object and the first object, they're just the same. Then all what we need to do is the same tension which is here is exactly the same as the one which is there. So what is this same tension equal to in the first place? It is equal to the friction force. So I'll get the same friction force and just replace it on that given position. I'm going to move this up a bit, meaning that mg in this case is the same as the friction force. How do you calculate for the friction force in this case? We know that friction force is equal to coefficient of static friction, which is mu s, multiplied by the normal force. So since this object is on the horizontal surface, we expect the normal force to be equal to the weight force itself, meaning that friction force is going to be equal to this guy here is equal to 0.2, and then the normal force, we said normal and the weight force are just the same, say 20. When you happen to punch this on a calculator, you get something like this. Okay, so here is our calculator. So if I say 0.2 multiplied by 20, I'm getting a force of 4 newtons. So when you get your 4 newtons, you expect that this is the same force which you are going to put on the part of a friction force, which is here. So what is the mass? Mass here is 2. I'll say 2. Sorry, it's not 2. It's not 2, because here we are dealing with the mass that we need to calculate on that part. So I'll say mass is not known, but G is known, which is 9.8 equal to friction force is 4. Sorry, from the question there, I think it is clear that we're supposed to take this one as 10. So I'll say 10 in here by 10, meaning that the mass itself is equal to 0.4 kg. This is the mass that we were asked to calculate in the question if the system is at rest, meaning that there's nothing which is being done. If you're the first person, or if the system, if the system itself is moving automatically, we have to make sure that we indicate even the forces. For acceleration, say this is going to move in that direction, this one will move in that direction. Don't forget to subscribe to our channel. If it's your first time, you can also try to share with those people that are in need of this same problem, so that you can help our YouTube channel to grow. Thank you. Bye bye.